All right, so today we are going to learn about the periodic table of the elements. Okay, how does the elements uh, are organized in a table? You learn about what is an atom, right? You learn about what is an atom. An atom is the simplest and smallest particles, right? Composed of protons, electrons, and neutrons. So the number of protons in the nucleus is equal to the atomic number, which give you the identity of the element. Okay, atomic number or number of protons is the same thing, yeah? Don't get confused. Okay? Normally, the number of protons equals to the number of electrons. Normally, yeah? Normally, usually, the number of protons is equals to the number of electrons. Why? Because in a neutral charge, if you have more protons, what ions do you make? Cation or anion? More protons and less electrons. When you give out electrons, you have more protons, right? So what do you become, cation or anion? When you give out electrons, you get more positive, right? So you take out
Cation.
more negative, more negative. So you get more positive, therefore you get a cation. So, but normally when in a stable element or in a normally elements has an equal number of protons and equal number of electrons. That's normally, yeah. So usually the structure within an atom is you have a, a nucleus, right? The nucleus of an atom. Today, people in quantum chemistry, now people study what does a proton made of, what is neutron made of. That's what we call quarks and etc. etc. But for now, just understand that you have a nucleus and then you have an electrons revolving around the nucleus. Yeah. Now you understand that. So that's what the atomic structure looks like. So you have a central nucleus. Nucleus has protons and neutrons, and then you have electrons revolving around that. Now you understand that. So you know that the proton is positively charged particle, and it is inside the nucleus. Neutron is neutral, no charge. It is also inside the nucleus. Electron is negatively charged particles, and it orbits around the nucleus. You understand what an orbit is, right? Comprehend na mo orbits to?
Yes, true.
Okay, so that's basically revolves around a nucleus. That's what the orbit means. So what is a periodic table of elements then? So elements are substances that cannot be broken down any further by chemical means. Yeah. So that means that elements is just different atoms with different number of protons. So you have to put the elements is just basically giving a name to atoms that with different number of protons or different atomic number. Okay, and this is the simplest forms of substance. You cannot break down. For example, coffee is a substance, right? But coffee is an element or no?
Yes.
No, coffee is a
No.
substance. Coffee is a substance. But you can break this coffee down into sugar, coffee, and water, right? In sugar, you can still break down sugar with sugar molecule, different sugar, fructose, lactose, and etc. And then within that fructose, you also have different elements. You have carbon, hydrogen, oxygen. So this one you cannot broken down into. So that's the simplest elements that cannot be broken down. That's what it means. That's what the elements means. Okay, so what is the periodic table? So the periodic table is simply the arrangement of these elements, how these elements are arranged by increasing atomic number and similar properties. Yeah. Periodic table is arranged by what? By different atomic, by increasing atomic number and properties that are similar. So two things. Periodic table is arrangement of these different elements by their different number of atomic number. What is the other number of atomic number? Number of
Number of protons.
protons. It's the same thing as atomic number, yeah?
Yeah.
All right. So this is an element. So each element in a periodic table, we'll have an information such as atomic number. In a periodic table, I asked you to print it. Have you printed it? Have you printed it?
Not yet, teacher.
Not yet, teacher.
But make sure print it for next meeting, okay?
Yeah.
Yes, sir.
Make sure you print it. So within atomic number, you have within a periodic table, each box of the periodic table will contain information such as atomic number, the symbol, the name, and the average atomic mass. Oh, you also learn about different isotopes and how they calculate the mass of an atom, yeah? Last meeting. So atomic number is the number of protons found in the nucleus of an atom. What is the unit used to measure the mass of an atom?
AMU, atomic mass unit.
Yes, atomic mass unit. Okay, that's the unit that we use to measure the weight of an atom, which is equal to 1 AMU is equal to, anybody remembers?
1.66054
054
times 10 to negative
times
24
-4
kilogram.
kilogram. Yeah.
Yeah. So that's very, very small mass, yeah? So average atomic mass. So within that small box, you have all of this. You have the atomic number usually here. That's the symbol C for carbon. The name is carbon. And then you have the average atomic mass, 12 AMU. Okay. Now this is a periodic table. This is what periodic table looks like. Currently, there are currently known 118 elements, 112 to 118 elements. So basically, this is lanthanides and actinides. Their place is supposed to be in this region. It's here, but so because of the weight, because of the if you otawa na ba kanya luan tarlalo, so they just bring it down over here. Okay, this is how periodic tables are divided into. If you notice, there is different colors corresponding to different properties, right? So earlier when I say periodic table is divided based on their atomic number and similar properties, their properties of that element. So for example, if you look at the color, this color over here, this is referring to what we call an alkali metals. This color over here, we refer this to alkaline earth metals. This color over here, we call them transition metals. This color over here, we call them pore metals. This color over here, we call it non-metals. These colors over here, we call it noble gases, yeah? So when you see the color here, when you have a black, that means the natural state that it's in is solid. Red, the natural state that a particular element in is red. So for example, look at hydrogen is color red. It is a gas. TC, that's a synthetic material or synthetic element. What is TC? Where is TC? TC. Do we have a TC over here? Nope, they don't have it here. But if you look at black over here, those are all solid in nature. All right, so that's what periodic table is. I think you should just print this one. This one is much better and much clearer. All right, so let's understand more what this thing is. How does this periodic table arrange? So the elements are put in rows by increasing atomic number in rows. So the horizontal rows are called periods. That's label 1 to 7. And the vertical rows are called groups. That's label 1 to 18. So this is what you call 1 to 7. We call it that periods. Okay, so when you look from So from top to bottom, if you look at from top to bottom in the group, each group 1, 2, 3 to 18, each group is arranged in a ascending atomic number. You see, hydrogen has an atomic number of 1, lithium is 3, sodium is 11, potassium is 19, rubidium is 37, cesium is 55, and francium is 87. So when you look at here, this is in arranging in according to atomic number, right? So in groups and in periods. If you notice also in the periods also, from left to right, you have 7 periods, yeah? This one you call period. So period 1 from hydrogen is 1, and then it goes to helium. That's 2. And then from lithium to beryllium, lithium is 3, 4, and then 5, boron, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. Okay, that's element in the period. So that's how they organize. Okay, so the red lines show the different periods. That's this red line show the different periods. And the green line shows different groups. So how many periods do you have?
7.
7 periods. Don't forget that this is also this one is also part of the period 6. This one over here is also part of period 7. Okay, so you have 7 periods. How many groups?
18.
18
18
groups.
groups.
Okay, and atomic number in periods and groups is arranged according to their increasing what? Atomic number.
Atomic
Yeah,
numbers.
increasing atomic number or number of protons. So basically when I say lithium 3, that simply means how many protons do I have? 3 protons.
3 protons.
Okay, that's what it simply means. All right. What about next? Okay, so this is so you already know about this. Yeah, the 3 different substances of matter. All right, substances are made of particles, and each of those particles are made out of molecules. So basically, if you look at the solid is not, there's not much of movement inside that. So in liquid, solid is very tightly packed. Yeah, solid means ni basic malulos. Okay, so it's like and you also have a gas. Gas is much more spread out. Near moving is much faster. So in solid, the particles are held very, very tightly, very close together, regular arrangement. They vibrate, but they cannot move from place to place. Particle held weakly. For liquid, particle held weakly, very close together, random arrangement. They also vibrate, but they constantly move past each other. Like this one, if you notice here, they move past each other. So gas is different. Gas is no attraction between particles. They are very, very far apart. They are random arrangement. They also vibrate. They move quickly in all directions, like what you just see in this image. So just simply means that obviously you cannot see these kind of things with your eyes. You only need a very, very, very advanced microscope to see this. But the idea is you see that for a solid, everything is very tightly held together. For a liquid, they move around like this. All right. So a good example of that shows the different states of matter is you see here this ice over here. So you have a liquid, the water is liquid, all of them are liquid. Water is also liquid, but you also have an ice, which is also water, but in the solid state. And you also have gas, water vapor in the clouds. Just like shown in the picture. Right, so that's the physical state of matter. Any questions so far about periodic tables?
I have, teacher.
Yes.
Why in a period of element? Wait, teacher. Why the color in periodic table of element is a pink, purple, the color.
Oh, the color is in it just to differentiate different periods.
Okay.
Okay, this color is different to differentiate different types of elements, but this one is just simply to differentiate different periods. Yeah. Do you understand?
Oh yeah, thank you.
All right. So elements are similar. Elements have similarities. Elements that we put the group have similarities. Their properties are similar. They're both their chemical properties and also their physical properties. Yeah. Elements in the same group have similar properties. Remember, groups are in columns. Okay, columns. So for example, their chemical property, you remember what a chemical property is? When you burn something that has a chemical reaction, that is a chemical. For example, burning something, that's a chemical reaction. When you burn a wood, when you burn wood, you transform the chemical structure of that wood, right? You transform it from solid to dust. So big chunk to very dust chunk, right? Physical properties are characteristic of something that can be observed without changing the substance into something else. For example, if you measure the length of something, that is a physical property. Or you measure the color, or you measure the mass or volume, that is a physical property, not chemical, yeah? So elements are grouped based on their physical and chemical properties. Okay, for example, the big ones are metals, non-metals, and metalloids, yeah? So basically, the major categories of elements are metals, non-metals, and metalloids. So metals are, you know what metals is, right? Like, for example, iron is metal, steel is metal, zinc is metal, right? Non-metals are elements that do not share the properties of metal. What example of non-metals are what? Chlorine is non-metal. Carbon, oxygen, nitrogen, those are all non-metals, yeah? And then you have metalloids. Metalloids are acting as in between metals and non-metals, are elements that share some, but not all properties of metal. Metalloids only share some of the properties of the metals, but not all properties of metal. It's just like in the middle between the two, the middle between metals and non-metals. So basically, they share properties. So what are some of those properties? Let's start with what is the properties of metals. So metals are lustrous, malleable, and good conductors, meaning good conductors of electricity. Right? Usually, when you do electricity, you use a metal or a non-metal material. You use copper wire, right? Copper is a metal because copper is a good conductor of electricity. It is a good to transfer electric current. Okay. The lustrous means it is shiny. So when you see a metal that is shiny and is reflective of light, that is usually comes from a metal. So for example, you look at the coins or jewelry, those are shiny and reflective. Metals also malleable, means it's capable of being shaped. So for example, some metals, for example, aluminum foil. Same with aluminum foil. Do you use aluminum foil in your kitchen?
Yes, teacher.
Yes,
Yeah,
teacher.
that's a metal. You can foil it. You can shape it in different. That's what one of the properties of metal is. It's malleable. Metal is also a good conductor. Means it's being able to allow electricity and heat. Not just electricity. It's also heat. Now, if you use the steel at the filamodon, tetun dia sana buat tidak kanurus filamodon yan. Kanurus filamodon imi usa the besi ho ida ai. Imi tahu ya tasularan besi ni imi karba lakleor manas tia lo sele. Mas ai la manas sida.
Yeah.
So that means metal is a good conductor of heat also. Net better transfer heat ne dia. Compara ho ai ni ka non-metal, which is just carbon and hydrogen. Okay, so they are good conductors of heat and electricity. Okay, so an example of metals of group 1 we call an alkali metals. That is group 1 in the periodic table. So that starts from lithium, sodium, potassium, rubidium, cesium, and francium. So group one, group one, we don't include hydrogen, yeah? Because hydrogen is a gas, it's not a metal. That's not alkali metal. So group one, very important. Alkali metal does not include hydrogen. So group one is very reactive metals. Yeah, group one is a very reactive metals. Maybe they don't exist in nature by themselves. They always combine with other elements to exist in nature. Compreende? Maksudnya, por exemplo, nunca hetan lithium mesak los dito maka-exist. No. You will never find that, okay? You will always have lithium will be, for example, it's bonded to an oxygen or lithium oxide, or it bonds to lithium hydroxide, or it bonds to lithium hydride. So it always bonded, it exists by binding into its other elements or other molecules. They don't exist as on their own in nature. For example, a good example of alkali metals is sodium chloride, table salt. So table salt is made out of what? Sodium and chlorine, NaCl. You have sodium is a metal, but chlorine is a non-metal. Again, sodium cannot exist on its own, right? It has to bond with something else. For example, sodium bonded to a chlorine, that's how it exists. Sodium bonded to a chlorine combined, when you make what? Table salt. Okay, that's a group one. That's an alkali group metals. Now group two, any question in here? Any question on this, on alkali metals?
None, teacher.
No, teacher.
All right, group two is alkaline earth metals. Alkaline earth metals is in group two. That's the beryllium, magnesium, calcium, strontium, barium, and radium. Reactive elements in group two, they are called alkaline earth metals. Okay, elements in group two is called alkaline earth metals. That's why they coded in different colors. So they are reactive metals. They are reactive metals that are always combined with non-metals in nature, just like group one metals, alkali metals. They don't exist on themselves in nature. They always combine with other. Several elements are important. For example, calcium. You find calcium in milk, right? Calcium. Usually, when people ask you to drink milk, that's because of the calcium that contains in milk, that supports your bone density, the bone structures of humans. That's why people ask babies to drink milk to support bone density, to make your bones stronger. So your bones is made out of calcium. Yeah, a lot of calcium in the bone. That's the human bones, animal bones. They pretty much make the same calcium, the similar calcium. Yeah, majority of them are calcium. So several of these are calciums are like mineral nutrients. Yeah, some of the alkaline earth metals are some of the most important mineral nutrients. Yeah. Nutriente by Emaninia ising, yeah. What is for example, sometimes people also need calcium, maybe medicina balu, lithium, larang. Ions balu nebe mineral water nene alkaline earth metal siya larang, ya. Ini biasa ini pernah nonton from mineral water?
No.
Yes, teacher, I've heard of it.
No, o pernah natin le minerale ni natin le minerale.
Oh, yeah. I know, teacher.
Ne kan ide be amen tatang ho mineral sira larang ho to ne metal sira ne be ho carga positivo ato refreshing. Hane somos energy drink, ya. Energy drink ya Timor terkenal ni manan sira ida azul ne. The blue energy drink dan sira na.
Paus milk.
extra Joss ni hawat tene ini extra Joss ni energy drink. Ida fal ida be ya aqua azul be langsung hemulit aja ada laten sela fantan kan. But
Oh,
yeah,
my John.
my John,
John.
yes, my John,
Yeah.
yes. My John masih fangen timur ka laten.
No.
Okay, laten to siya. So my Zone, that's an energy drink. So usually an energy drink contains ions or nutrient, mineral nutrients, yeah? So transition metals, that's all the pink color over here. That's group 3 to 12. So those are less reactive and much harder metals. So for example, if you look at copper or cobalt, nickel, imironan lefon sa neto, cobalt, nickel, biasa Indonesia siya, Indonesia ni Rico yan nickel.
Yes.
Nickel, Indonesia has a lot of nickel. Agora dadak foi na lá, a companhia mineiros ira ia Timor foi to discover manganese. Manganese is that's no manganese, magnesium. Manganese is a metalloid. That's a metalloid. Yeah. So transition metals are, for example, iron. Iron. Baba ini hari iron yan be. Iron yan be. Baba ini hari basis yan mauja halo umahal kareta. That's an alloy. Yeah. That's what we call steel. Steel ne kombinasyon entre iron and carbon. Iron o carbon tahu mutuk ni masai steel ne perhalan ini properties ne tos li aumenta durabilitan. But ini elementos majority that's iron. Tama ne mababang Maria kareta ni be sorry sir ne ni frozen that's a steel. That's a combination of iron and carbon. You have cobalt. However, for analyze the Timor siya discover manganese. Kata siya discover manganese baraklas siya area balo. Daru may los palos sila mane kaya nabe mane. You have chromium, vanadium, yeah, platinum, iridium, mercury, cadmium, zinc. Zinc na dalam rumah yang mauza kaleng. Kaleng tak kau sana dalam rumah yang mauza halo zinc mauza. Dalam rumah yang mauza metal yang mauza saya stainless steel tu sih. Tapi zinc dalam rumah kaleng na mauza halo zinc. Kaleng balu uza zinc, kaleng balu uza steel, stainless steel. Okay? Agora, tu irfane grupo 13 to grupo 3 to 12. Agora para grupo 13, ida nema bolo narang boron family. Ida nene properties of both metals and non-metals. Sila ne metalloids, yeah? Yeah, klarang. The rest of elements in these groups are metals, yeah? Elements in group 13. Boron has a only so a group boron family, so boron mesak mag metalloids, yeah? Boron, only boron has a properties of both metals and properties of non-metals. The rest of the elements in this are metals. Grupo sila metals. For example, aluminum, gallium, indium, and then thallium. Those are all metals, yeah? All right? That's boron family. And then the next one is group 14. That's carbon family. And in carbon family, only carbon and silicon is properties of non-metals. Okay, so it can act as a metals and non-metals. Where do you, so you know carbon. Where do you find carbon? Carbon ni mihetang na. You see carbon everywhere. Your human body is made out of carbon, yeah? Human body, animals, trees, food you eat, those are made out of a lot of carbons in there. Where do you find silicon? Silicon is a good property of semiconductors, yeah? Ida ne dalabanak yung mauzi he electronics ne. Transistors that you use. When you look at your telephones, the CPU, central processing unit of a CPU is made out of a bunch of tiny transistors. And transistors are made out of silicons. Okay, if there is no silicon, there is no cell phones, no internet, no laptops, no radio, no TV. Okay, so silicon is very important. You use it every day. Contains so carbon is the basic element in all organic compounds. Organic compounds means organic in nature. Organic simply means materials that contains carbon, hydrogen, and oxygen. That's organic. That's like just like human body. Human body, if you analyze it, it's just made out of carbon, oxygen, and hydrogen. For example, water is an organic material. Water has H2 or two hydrogen atom, one oxygen molecule. For example, sugar. Sugar is an organic material. What else? Gas and hydrocarbons.
How
What?
about salt? So, masing.
No, masing is inorganic because you have the sodium metals in there. Masing ne inorganic. Tambah ya sodium. Sodium ne ohing itanya alkali metals. No?
Oh yeah.
That's not organic. That's masing ne kategoria ba ya inorganic. Silicon and germanium are important in semiconductor. Yeah. Before yan ba ya cobalt. Cobalt ne mas pabaya bateria telephone niya. So in the battery, every battery that you use in your laptop or cell phones is made out of lithium cobalt alloy. So you have a lithium oxide and then cobalt oxide in the anode and cathode side. Yeah. Nebe bateria nebe mi biabang usa nene bateria telefoni, bateria laptop. Babang ya bateria uluk liu ne kan telefoni ne bateria ne tabel hasai tialo sele. You can take it out, right? That part of the battery is made out of cobalt and lithium oxide and cobalt oxide. So when I say alloy, when bahira ko lelefon alloy ni artinya sira combina buat ruan hamutuk, join hamutuk. Yeah, that's what we mean by alloy. Alloy simply means together or join together. All right, that's the boron family, that's the carbon family, and the next one is the nitrogen family. So nitrogen family, if you notice, the color in green, those are all non-metals, yeah? Colors in greens are non-metals. So carbons, silicons, those are metalloids. And then next one, you go to nitrogen family. That is the group 15. That's where you have nitrogen, phosphorus, arsenic, antimony, bismuth. Those are group 15. All right. So where do you find nitrogen? Nitrogen make out of 3/4, 79% of air that you breathe is made of nitrogen. Nitrogen gas, N2, yeah? Any that is air that you breathe is made out of nitrogen. So phosphorus in the matches, icosane contains phosphorus, yeah? So the matches contains phosphorus. Arsenic temos babae uja halo racun serne. That's very arsenic is a poisonous elements. Okay, that's group 15. What about group 16? Now that's oxygen family, or sometimes we call it chalcogens. Chalcogens, that's a group 16 elements. You have oxygen, you have sulfur, you have selenium, you have tellurium, polonium. So you find it where? Oxygen is necessary for respiration. When you breathe, bahira ita dada is, los galay? Bahira ita dada is, ne ita dada tama oxygen. Oxygen halo reaksi ho carbon ita niya larang. Ita hasay fali sayda. Carbon dioxide, CO2. That's technically how photosynthesis work, yeah? Photosynthesis ema dada is ne tama ita dada is ne oxygenio. Ita dada is oxygenio. Oxygenio halo be tama ba ita niya larang. Halo reação ho carbono ne be ita iya. Oxygenio plus carbon dioxide. So we make carbon dioxide as a product, as a gas product. Okay. Sulfur. Ejemplo dia kira bahira mi kuan hare buat mantolong ni is. Imirai mantolong kano clear lo ni dois las galay. Dois. Mantolong dois arne ni or buat horon ne be dois ne mayusi sulfur. Bad odor from mantolong ne usually Por exemplo, babaeng siya mabaho na belulik manas. Be manas fating e marobo ka. Siya bikeken yan eh. Siyempre na ba na?
Nagbaho, teacher.
Sinagbada? Imna sinagbada?
Yes.
Impera no na imnya kolega siya
No.
kwento bemi?
Yeah, pernah.
What do they say? Siya diyan sada. Siya horong isan din sa sada.
Sila nagkwento di is maybe sila din bimalas yung marobo is.
Be manas marobo ni imi base ba basic imi horong isan sa is mantolong. Mabe nabalos mantolong yan. Ano yung is sulfur niya? That's the smell of sulfur. Never next time imi kolya ko na babe. Imi kolega said, oh, ami horong fal is mantolong. Imi said, no, that's the sulfur. Ne elemento kimike na wala na sulfur naman eh. Okay? Okay, that's group 16. Now, group 17, we call that halogens. Now, halogens are very reactive materials. Elemento ihabe grupo halogen sila reactive tarla. Sila ne very reactive. Sila ne always found combined with other elements in nature. Yeah. Example ida maka, for example, chlorine. Sema iha uma ne iha kolam rena imnaro isal satu ida iha uma kolam rena iha galaya.
Lahir na, teacher.
Laya?
Yeah.
No.
No. Okay, but imi pernah nani na kolam renan?
Yes.
Yes.
Babay pernah imi nani imi horong is rumo iha kolam renan gale.
Yes. Horong.
Yes, true.
Yeah, that's chlorine. Okay, babay yung usa chlorine atu bacteria sila iya belana. People use chlorines to kill the bacteria out of the swimming pools. So when bacteria see chlorine, they are dead. Okay, that's group 17. We call that halogens. And the next one is group 18. We call that noble gases. Yeah. Noble gases are very reactive gases used in lighted neon lights. Neon signs yung pernah hariyo na to? Neon lights, neon signs. Ne gas ito may halarang eh. Gas ito halarang, you tahu electricity ba? That's why you have different colors of green, pink. Those are made of neon. Yung pernah ronan neon lights, yung pernah ronan? Bahira yung iba sinasira niya sa rumah ka. Club, bar sila na may pass ba, yung hari lampu kalakan sila na isang nene. Those are neon lights. Babaeng emo usa helium, ya. Babaeng emo usa helium ato ese balon sila ba emo halimar ne. Alright, those are noble gases, yeah. Okay, now you understand. So basically, periodic tables are made out of different groups, yeah. So group number 1, that's alkali metals. Group number 2, alkali earth metals. Group number 3 is transition metals. And then you have transition, so group alkaline metals, alkaline earth metals, transition metals. And then you have boron family, carbon family, nitrogen family, oxygen family, and halogens. And then noble gases. Yeah. Okay. Any questions so far about what periodic table is?
None, teacher.
All right. So that is a periodic table of elements. All right. I want you to maybe print this and share. I can probably share this. Okay, wait. Let me find if there is a better periodic table that you can print. Okay, hold on. Let me see. Okay. Bahira may print ka ya. We will use this, all of this. I need you to print all of that. And you can bring this in for the class. So for this class, you need to print everything that I sent you. So you need to print this. Or maybe let me just put it in one document, yeah. Hold on. Please bring in a periodic table ni bring the board na na para it's better. Please print this and then always keep it with you when every time we have a class. Okay?
Yes.
Semana wen thank you na. I'm expecting you to have that next week. Okay, Himalaya. Let me. So we have this. Uh, okay, hold on. Oh God, this one is very, very bad. Okay, give me a second.